So I would say like this part of uh, IT is new and very young and growing and would grow in future. So like earlier, you can say people were doing uh, like software engineers were involved in data part, and then I think there has been a shift in last 10-20 years where people has realized the importance of data, and that's how like data engineering has evolved over the period of time, from like started as a generalized skill to now it's growing towards more specific or specialized skill these days. And it covers like broader area. It's not just only collecting data or pushing data. It has grown a lot. It covers security aspect of the data, reliability, quality, and and you can say a complete data ecosystem. It covers not just data engineers, it covers data analyst part, data science as well somewhat. So as a data engineer, you'll have to work on a lot of related stuff. Yeah, move to second slide. So guys, I can talk like throughout day, and then explain each and everything, but to get some meaningful information which will help you guys. And so if we're gonna cover like these 5 aspects today, and so that you guys have good knowledge about the data engineering and the related uh, uh, technologies. So we'll cover like in the first part, we'll cover introduction, where I'll give you some background about the data engineering, and then the difference between like most of the people I think might be very curious to know what is happening around, and then what is the difference, why it is a separate field altogether. So I'll cover in the difference part, and then we'll go into more specifics about this data engineering technologies, what industry is using, and and the type of tools you should be exploring to get into the data engineering. And then we'll cover slight history about how data engineering evolved, and then we'll cover some career tips, like how you can proceed or in this technology and grow. So we'll cover these 5 broad topics today. I know covering this part is not easy within 2 minutes, but yeah, I'll try to cover as much as I can, and then try to answer each of your questions. So before we move into the introduction part, I would like to introduce myself, and then I'll go into I'll start the session with the introduction. So before we move ahead, so I'm Pradosh Tiwari. I have around 10 years of experience as a data engineer. So I have been working with like multiple firms. I started with my career from service-based companies, worked in couple of service-based companies for initial 2-3 years. Then I moved to organizations like fintech, worked there for 4-5 years. So currently I'm working for Amazon from past 1.5 years, and then I think I have learned a lot. I would say I tried data science as well, then data analyst part, then I write reports as well. So over the period of time, I got a chance to explore a lot many areas, and this is the beauty of data engineering. that you'll get chance to work on lot many things, and every day you'll have a lot of challenge. It's not like you're working on some stuff and it will continue throughout your life. And another beauty, which I'll say, this is only uh, mm, section of IT industry which values experience. So you can acquire knowledge by reading, or reading books, or maybe some videos, or writing some code. But data engineering is something more than that. Yeah, learning, acquiring knowledge is definitely necessary, but in data engineering, you evolve yourself as a professional, learn things, and then this experience is valued, because data has thousands of scenario. In a data you can have so many issues, or you might have to pull different insights. So based on the experience you acquire some knowledge, and that is very valuable. So this is one of the uh, uh, part, I think, beauty of data engineering, which is I think different than other uh, job profile within the industry. So yeah, let's go into the introduction part now. Yeah. So I think many of you guys has already simplified the data engineering. So to start with, I also kept it very simple, so that you guys are not afraid, and consider and relate like this is one of the easiest things. So like you guys know, like like I saw a few messages, like data engineer works on capturing data and then creating based on the need of the data analyst or data scientist. And this cloud, so there is some machine which is inside the cloud or on prem, and then it runs and does a magic in the data engineering cloud, and then data scientists do some interesting things, and then everything is ready. So I think most of the people think it is as easy as this diagram. Yeah. So you can see, like if you go with a definition wise, like designing building system, collecting data, raw data from multiple sources. So you can see in the box, like there could be hundreds of, like one person mentioned, like it's always JSON data. No, it's not like always JSON data. It could be a Parquet file, CSV data, could be data from some source system like Salesforce, and there could be many other source system within the organization. Could be using Redshift, RDS, some NoSQL databases. Data can be structured, unstructured. So this data is raw and doesn't have any meaning. So how this data be consumed to make it more meaningful? So data engineer, I think data engineer comes into the picture, where it gives value to the data, or it process raw data so that business can pull meaningful insights. So raw data is of no use, not a valuable uh, piece of information. So data engineering adds a value. So this cloud you can see in the middle, it's not something machine or something. It's a value addition part which adds value, and then this value added information is sent to the business or data scientist or other part of the business. Yeah, can we move to next slide?
Yeah, just a second.
Sure. And meanwhile, I'll request audience to just put your questions in the chat so that uh, whenever we'll have Q&A, we'll pick few questions from here, and then yeah, that would be good. I think by that we can save a lot of time as well. Yep, sure. So I think it's not page 3 after introduction. Can you open page 4?
1
Yeah.
minute. Stuck.
Okay, so yeah, means yeah, you can fix that issue. Meanwhile, I'll cover. So I think people generally are lot of people are fascinated about data science. I know, like, you might be hearing data science, data scientist, this term a lot, but I can say data engineering is a very close or first cousin of data science, actually. So data scientists, they do lot of data engineering. So, and then I think the 30% part is there, and I think statistic and the model writing. So you can see, like, in this diagram, data engineers are in very high demand these days. So you can say other type of job profiles, like front end cloud architect. So I think data is new oil. People, industry has understood that, and in past few years, the demand for data engineers has grown a lot because industry is realizing the value of the data. And the tech giants like Facebook, Google, they consume a lot of data and they want to pull some meaningful information. So that is why this role of data engineer has evolved. And you can say, in this is one of the survey has been done regarding the opportunities in the market, and data engineering is one of the top job profiles in the market and growing. And as I think data is new oil, and data is growing. The need for the data engineers will grow in future. So you can see, like, few interesting roles, like Python developer, like Android developer. Yeah, they are also good, but I can say it depends upon the interest. Data engineering, I think, involves knowing some of the duties which is done by the specific engineers or developer mentioned in this. So yeah, I think uh, it I would say it's a industry which is new and would be growing for 10-15 years at least more. I don't see anything which can reduce the impact of data engineers for next decades. But yeah, uh, as we move on, I can now tell you more about data engineering. So we have been hearing data engineering, but there are multiple roles which contributes to data engineering. Data engineering is not just about you can say only having data engineers. It's it captures a lot different roles. So data administrator, data modeler, data scientist, data architect, and data quality engineer, BI engineer, and then data engineer. These 7-8 different job profiles comes into the broader data engineering umbrella. These job profiles or roles has a different set of responsibility, and sometimes we have to play a part, like one of this part in our team. So it's a, I can say, a soft boundary created within your team in which you would be working in future, so that people can work on the interesting stuff. So as you can see, suppose if you read through the function of database administrator, their tech skill, it it would be quite similar with other in this list. So because their responsibilities are overlapping and based on the requirement of the business, people shuffle this responsibility. So database administrator in data engineer take care of the maintenance of and performance of the databases, and along with that, they make sure the service level agreement with the different sources are made. They take care of performance tuning and networking related design. And data modular in the sense is like, data, so data can be in different formats, data can come from different business or function within the organization. So let's take an example. So within an organization, you see lot of different departments. It could be HR, IT, finance, and then uh, many more. So if we consider this part, the data coming from these system would be different. So data modular will look into this data, try to create multiple database objects and link them, so that we can pull some meaningful insight relating those data from the different departments. So that's how data modular comes into the picture. And if you go about the data scientist, yeah, means you might have read about the statistic model machine learning. So they consume refined data and then try to pull more meaningful insight using machine learning models. So this is one of the specialized role which comes into data engineering. And then the data architect. So data architect is you can say a brain in designing complete data lake. So whenever there is any work starting within your organization, data architect will look into this, try to understand what can be built in and how it can be built. So architect is like, whenever you go and build actually your house, first you go to architect, and then you start building your house. That is how data architect work. Whenever you are trying to build any big data solution, you'll go to a data architect, comes into picture, they design, and then they share that design with the team, get it reviewed, and then that's how it works. Can we move to next slide? So in the next slide, we have data analyst and then data quality engineer. So data analyst actually what they do, they are like they go dig into data and then give answers to the business questions. So they did analysis, and the data analysis part, and they go into the dashboard, work closely with the business or end user and help them. Data quality engineer, they looks into data, and like there could be so many system, they can send a wrong data to us, so it's difficult to measure the quality. So that's how data quality engineer comes. They try to prevent data quality related issues, and they also use a similar set of technologies like SQL, data quality tools, and others as well. So BI engineers, business intelligence engineer, they are basically they create the visualization. So once data is clean, they go and create uh, you can say reports, various interactive dashboards, so that business can go and look into that. Here comes the data engineer. So whatever till now I told different roles, data engineer can play any one of the roles, and their responsibility shifts across. So in the skills, it's a very broader. They can play a role of data quality engineer, sometimes BI engineer, sometimes data analyst, sometimes given a chance they can also explore data science as well. So it's a broader role. So whatever I told, like admin, modular, data architect, uh, everything, each and everything evolves around data engineer, and they shuffle. So in the simple term, data engineers work like writing data pipeline, writing big data solution, integrating, creating data lakes using cloud or on-prem technologies. So it could be writing solution over Hadoop, writing reports. So I think data engineer has a lot of a broader role handling this uh, problem. So can we move into next slide? Yeah. So now, now the question comes: why it is important? Because yeah, means like data is in raw format, but what no, what else? Why means so there are few examples which I listed here. So uh, we'll go through this example, and then you would be able to understand why it is so important to have a data engineering solution to many of the business problem. One such example, like one system contain information. Maybe there are multiple system. One contains billing information, shipping information, some contains order information, and some contain customer support or third party solution. So in a, say, suppose you can take an example of one e-commerce website, say Amazon, Flipkart. So whenever you place order, so you get an invoice. It has billing information, it has shipping information, order details, number of products, maybe you can say vendors detail, delivery, estimated delivery date. So like you this seems to be a simple one page, but this information is coming from different disparate sources, and you are getting a final finished product through a form of invoice. So I think that's why data engineering supports this complete process, making it possible for the consumer of data like us to get this information in well polished form. So you can understand, say, billing in an organization in a normal world, these information is stored in a different system, and in a click of order you get this information instantly. So the complete backend design is, or data is polished, cleansed, almost real time for you. And this data pipeline, complete pipeline, has been built by data engineers, so that you can go and consume this almost instantly. Yeah, shall we go on the next slide? So this is one of the, you can say this is the stepping stone each organization has to go in terms of data engineering. So data engineering is, you can consider it's an investment in terms of like means if you wanna reward your organization or grow, you have to invest in certain technologies. So data engineering is something where it won't give you results in very first day. It's an investment which industry does so that they can grow in future and have a better insights what happening within their business. So you can say this stepping stone as a starter, means people start with certain capabilities, build the infrastructure, data infrastructure, and in the second you can see siloed. Once people build infrastructure, I think the means at the starting people create some solution which is siloed for their business need, and it's not like coordinated across business. So in the second phase people work on the siloed data and then try to create a well distributed system so that information is shared across org. And then in the third mm, phase people realize the potential of unwinding this data from siloed departments to where people can easily go and access this data. There could be many undefined process, but North Star goal is to have built a system which has this robust analytical platform which supports our leadership to get meaningful insight and helps organization to grow. So this is, you can say, a journey which happens within each and every organization. So some organization might be already in the second or third phase, some might be already reaching at a fourth phase. But this is how in general data engineering uh, starts and then evolve over the period of time within the organization. Can we move to the next slide? And now I'll go into more specifics about what data engineer does. So how you can say this all business problems are solved by the data engineer. So it is not easy. The terms which are written here like acquisition, cleansing, conversion, disambiguation, and deduplication. So these are, you can say, a part of day-to-day activity a data engineer does, and then they work on it on a daily basis. So first I think whenever we get data from different data sets, so data acquisition, we acquire that data. So whenever in real world also you go and buy some property, you acquire that property. That's how in data engineering work, we acquire, we do acquisition of this data. Once we acquire that data, we figure out what is the problem with this data. Problem in the sense, like we already have one system which has XYZ format, but the data we acquired has a different format, maybe some different dates format, maybe some other uh, other like unstructured data maybe. So once we acquire that, we'll clean that data, so that uh, it is in a better shape, error free data. So cleansing means like in some of the attributes you'll find like data is incomplete. So that incomplete data might create confusion and create problem. So we figure out way to make it complete, or will might have to reach out to sources to reprovide the clean data. Once we have clean data, we'll have to standardize that data with our current system. Like we have to convert, because the data which is available from different system may not be useful as it is. We'll have to make it useful. We'll might have to convert, manipulate, or get into defined format. So let's take an example of, say, date in India is generally like in DDMMYYY format, like it starts with date, month, and then year. But in some part of world like US, generally it starts with year, month, and then date. So we can get dates in different format from different systems. So we should convert that data into a common agreed format with business. We'll figure out, we'll have an agreement and then convert that. This ambiguity is like when we so a similar data we can get in from a different systems, but it doesn't mean the data, both data are same. So we'll have to figure out similarity and the dissimilarity in the data, and then reduce the cases of disambiguity. Deduplication comes like we get lot of data, and there could be a case where the data could be duplicate or may have like same information in some or other way. So that's how like we remove those unwanted data, because unwanted data might change the meaning of your uh, information, or that will also increase the burden, maintenance burden on you, and then also lead to lot of like redundancy into the system. So that's how we try to deal with the duplicate data. So once this is done, so these all steps, these basic steps are done, then data is stored into a data lake. It's like a vault, you can say, a vault where everything is stored. It's like you have a bank account and locker where you keep all your important stuff, belongings in the locker, so that it is safe. So that's how like data lake or our data warehouse comes into picture, where once these steps are performed, data is stored into our data lake, and from there it is pulled. So here you can see, like in the diagram, data collection, then we prepare data, and then after that data exploration, visualization happens, and then people, once this is done, people do experimentation, data scientists work on it, work on the prediction part. So this is how data flows from end to end. So yeah, I think let's move to slide 15. I think I have already covered few things, and then if time permits, I can come back, because I can see lot of questions related to the tools, data engineering tools and the technologies in the chat. And yeah, and then at the last 15 minutes, we can have a Q&A. But yeah, so let's
Yeah.
move to slide 15.
Okay.
Yeah. Yeah, so I can see a lot of interest or curiosity for knowing the data engineering tool. So I have listed like general uh, type of technologies related to data engineering. ETL, you can say ETL, SQL, Python, cloud data storage, query engine. Don't get afraid about these. So many, you can think like, oh, there is so many technologies here, how I can learn and how I can be in this data engineering field. So now, if we go step by step, so as you have seen, the data processing happens through data acquisition, conversion, then standardization. So those steps. So for each and every steps, there are a different set of tools, technology being used. Okay, so if means you need not to run all of them together, so it's like step by step. So SQL and Python, I would say it's a heart of data engineering. So SQL, you have to learn along with Python. So Python and SQL, I would say it would work as a base for you. It's a, you can say, as you know, it's a language. So as you know, English, Hindi, this a language to interact with people. So like Python and SQL is would be the base of data engineering. And I like you have seen the course mentioned by the Manjunath. So this would be covered like in a very initial stage, and it would be and you would be using on a day-to-day life. So data engineer, I would say, most of the time they would be writing SQL and the Python code, and then utilizing it in some or other way in their day-to-day activity. Now if we move to ETL tools, so I think as the full form say, it's a extract, transform, and load. So what happened? It these tools you might have heard in the market like Informatica, Talent. These are the one of the most popular ETL tool organization. So they have different type of tools. So these tools connect with the source system, and then data is manipulated and loaded into your data lake. So this tool does that. So uh, you can say like whatever you can do through Python in different way. So you can see here Python can be also used for ETL tools. But why we have these ETL tools? Because these ETL tools will help you not writing any code from the scratch. In the Python, you might have to figure out the connectivity and the different thing. These ETL tools simplify your task basically, and then you will just have to focus on uh, more meaningful work other than writing code from the scratch. If we go about the technologies like cloud data storage, you might have heard about the AWS, then Azure, Microsoft Azure, and then Cloud GCP as well. So these these are the different cloud providers, and within each cloud provider there are tons of services. Like if we go about the AWS has some popular services like S3 for the data storage, then the Redshift, it's a cloud warehouse, then you have a Lambda which runs on the serverless engine, then you can also use EMR, it's like spinning your own Spark cluster. And for the last part, query engine. So for the query engine, you can have like a Hadoop system or Spark, anything, and then run your complete computation on those engines. So we need not to be expert in this area, I would say. We have to start our journey using SQL and Python, then evolve ourselves towards ETL side, and then I think cloud comes into picture when you have some idea about these tools. Then you can start exploring cloud services and the query engine as well. So query engine comes when you have a big data problem where you are processing terabytes and petabytes of data. So in so at that time you would use this a query engine to process through Spark. And if you are like if you have a decent knowledge about Python, I think learning Spark, working on any ETL tools won't be a issue. And as I think Manjunath also mentioned, I think this beauty of data engineering is you don't need prior coding experience. So like mm, if I tell about myself, I have a electronics background, and I don't have software engineering background. So over the period of time, I learned things and then became expert in this field. So like you can, if you are not aware about any tools and technologies, you can go start exploring and working on this. So in this diagram, you can see like data engineer must adapt to these various areas. So it data engineers grow like gradually. You can see in the foundational part, programming language, SQL, database, analytical tools, ETL tools. You so in this part you'll explore. So initial few months you'll have to explore this thing and learn more, and then comes into like a deployment part. So once you have good hands-on in this field, you work into like spinning your query engine, and then work into creating your own environment. And once this two part is done, you'll work on specific business organization problem, where you'll try to make your solution more effective. And once this done, so data engineer also work with the business directly. So you should work collaboratively with the business, understand, come up with a creative solution, and then also work on the emerging technologies like AI and ML once you have good understanding. Can we move into next slide? Yep. So here you can see the tools and technologies, whatever I mentioned. I think for data engineer, most of the things are overlapping. Like you can see like Hadoop, MapReduce, HivePig, then warehousing concept, and then you'll have to work on the Python, SQL, and data modeling. So yeah, I think as you grow, learn you can say in the top you can say Python, SQL. I think gradually once you start working on this technology, you will learn a lot related things. So I think conceptually once you start looking into any problem, data engineering problem, these things would be easy and automatically revolve around you, and then you'll need not to focus on each area one by one. You'll learn this thing together. Let's move to next slide. So now question come, data engineering, and what is the difference between data engineering and software engineering? So data engineer, we as a data engineer, we build data system and databases, while software engineers, they build application, Android app, product, software. So software engineering is a broader role. You cannot confine, like there could be 100 types of software engineer, but data engineer is a specialized role designed to build data systems, databases, and retrieve information. But in case of software engineering, it could be building system, application, website, or maybe some tools. And it's a very generalized skill, I would say, software engineering. And if we think about the type of work they can use, they can be programmers, designers, developers. But in data engineering, you will find business analyst, data scientist, and then data reliability engineers. The popular tools data engineer use are Tableau, Redshift, then Spark, Kafka, Hadoop. And in case of software engineer, they use GitHub, Stack Flows, Jira. We also use some of them, but very specific use cases. Not, I would say, not most of the time, but yeah, for some use cases. So Data engineer, we work on the query, distributing distributed computing, writing data pipeline, working on the machine learning problem. But software engineer, they work on building operating system, coding into some programming language, and then creating some tools. So this is I can say few examples which differentiates in software engineering and data engineering. So if we move to next slide, you can see the diagrams about the tools and technologies, different tools and technologies software engineer, data engineer use. You can see software engineer HTML, XML, CSS, Angular, PHP. But we data engineer, we use Hadoop, data warehouse, Hive, big queries, big data, business intelligence. There are few overlapping technologies which, because we work closely, software engineer, data engineer, we work very closely, so there could be few overlapping technologies like Java, JavaScript, Linux. But yeah, means that will have to gradually run, and the few use cases we should not be expert on these technologies to work with. And in the right side, you can see the type of roles. So data engineer play roles while creating data pipeline, creating a schema, performing ETL, while software engineer, they would be working on UI, some backend coding, deploying code, and the entire process. Knowledge, you can see like data engineer should have knowledge of database, SQL, cloud. And in case of software engineer, they are more specific to programming and related technologies like Redshift, RESTful APIs and all. So I think in a whole, you can see this most of the data engineering technologies, people should if they don't have any data in or software engineering or oops background, they can also come start learning, and then work as a data engineer and build their own career. So this is the beauty, I think, which attracts many people and me as well. Like now, means as a data engineer, I'm working on the real problem, and my solution are helping business save or generate lot of business. So if we move to next slide, so we now I'll go into how this data engineering evolved. Like what happened previously, people previously, they were just looking into data and then trying to give some insights from the data. Say suppose earlier people used to like 10 years back or 20 years, not 10 years, maybe 20 years back, people used to like consume data and just give analytical information like this number of cells in this region, and this is how we are behaving in this region, and that's how business used to drive value from the data. But as we go currently, it's a world of contemporary data engineers where they, so the role of data engineering has evolved. So now we work on data generation, then transformation, works on the data security, data management, architecture, orchestration, and somewhat data engineering. So now with data, we are taking it to the next level and working on a lot of different stuff, like I told you. So in the next phase, what next for data engineering? So I think in future, data engineering will evolve in uh, creating more reliable system, more real-time system. It could be like we would be working more on the predictive side. So data engineering has a lot to evolve in future, considering current market situation. The need and the security is becoming a lot of concern for the organization. You might have heard about the different data leaks from the various tech giants. So I think as the times grows, the need for the reliable data solution will grow, and that's how the data engineering will grow in future. So let's move to the next slide. Yeah. So as in this diagram, you can see it started, data engineering started around 80s, and initially it became like everybody started building the data warehouse for themselves without knowing the value of it. Then they started creating few values. Then they had some data, but they were not able to manage. That's how the master data management came, because they build lot of data duplication into this their system, and then they were not able to manage those things around 90s, so they created MDM solution. In 20s, people started building the data lakes, and then come picture then Hadoop system came, so people started creating SDFS system. And then finally, like present, you can say people are now building more intelligent data pipelines, data lakes, so that it gives some more meaningful information, predictive sites of information, and ease to manage system. So let's move to next slide. Yeah, so here you can see how it evolved, like in this century, like from 2000 to 2020. You can see like lot of thing, Hadoop system came into picture. Then FANG companies like Facebook, Amazon, they grew over the last 10 years from 2010 till now, and how they have evolved and the technologies involved. So next 10 years, I would say, for till 2030, it's, I think, there would be most growing period for the data engineers, because now as we are shifting towards more intelligent solution, data engineers are involved in end-to-end uh, architecture and the design. So the role would get broader in next 10 years. And then the solution, like tool agnostic solution, where people will work in creating robust solution and utilizing data, value for data will increase. So I think lot to be done in next years. And the growth wise, I can see this was one of the most interesting field in the IT, as per me. Let's move to next slide. Yeah, so I think here I have already covered like what's happening in the present. So you can see data generation, ingestion, transformation, storage, and in the horizontal, all these stages goes to security, data management, architecture, orchestration, software engineering. We data engineer goes through this complete like life cycle while designing any product. I think, yeah, let's move to the next slide. I think I have already covered this. So now career tips. So I think once you decide like moving into this field, so understand uh, like which type of job you want to do. So I have shared the multiple roles, like it could be becoming data science engineer, data scientist, data engineer, then BI engineer. So understand your interest first, and then decide which area you can go, and then start programming, like I told, like SQL, Python. This would work as a base for your career. And then I think from there you can move into any role as you want. And then I think once you decide work into this, you'll have to think about uh, understanding, researching more about that area, and explore, try some use cases. I think Guvi will do a lot of interesting stuff in like point 3 where you deep dive into that. But yeah, means as an individual also you should explore more into that area, understand that area, devote some energy, and then learn things. Last but not the least, I think at the initial I think starting of this session I told you experience matters. So data engineer, you can learn so many things by your own, but if you won't get like real time project experience in data engineering, you won't be able to like grow uh, or get good job in this area, because this is the only industry, data engineering field, which values experience, and people learn from experience. They get good understanding of data over the period of time. So I have 10 years of experience. I don't know even 1% of data scenarios. I have learn over the period of time, and then that's how I'm growing, learning day by day. So you have to get lot of experience beside learning, or deeping a lot into the different areas. So that's how I think you can grow in this career. So this is a beauty of this career. You won't be able to learn everything on a single day. It takes months, years to grab everything and then translate into a business problem. So here you can see some interesting pyramid of data science need. So as I told you, so as a data scientist, you'll have to be first data engineer, good data engineer. Then only you can become a good data scientist, because as a data scientist you should know how to collect data, how to move, store data, good quality data, explore and transform data. Then only you would be able to pull meaningful insights from the data. So I think these a few things are important once you grow. So you have to decide the area you want to go, and then make the decision how you gonna go. So each and every field or roles which I mentioned have their own scope, and then you can grow in each area as means as per your interest.